Methane. Scientists estimate that it's responsible for 30% of global warming since the start of the Industrial Revolution. I think you all agree that that is something that cannot continue and that we rapidly need to action. At Cadent, methane is the primary component of the gas that we transport, and naturally we feel a responsibility to be at the forefront of that battle. Cadent is the UK's largest gas distributor, and we operate in the area that you can see on screen at the moment. Within that area, we have a whole range of assets. Over 130,000 kilometers of gas pipe. We supply 11 million customers with their gas, whether that's domestic, industrial, or commercial. And within that region, we have a call center that takes 1.4 million calls on gas emergencies per year. If you look on our website, you'll see a similar set of phrases used quite a lot. We're committed to keeping you safe and warm. And we do that by maintaining our gas infrastructure so that the delivery of that gas is safe, reliable, affordable, and sustainable. Now, if you follow the money, we do that using two routes. We replace our aging infrastructure and infrastructure with poorer health, and we repair. When it comes to replacement, we have several programs, and we use our historical data to understand where our assets are not performing as well as they should and replace. But when we get that historical data, it's mainly based on where we've reacted to things that have happened. So our prioritization when it comes to replacement at the moment is fairly reactive. We will replace in months or years after events have happened. When it comes to repair, we rely on your very sensitive noses to tell us when gas may be escaping from our network. And when you do notify us, we'll be there, in most cases, within 1 hour to make the situation safe and to subsequently repair. Now, because we rely on your very sensitive noses, our workload there is also very reactive. And it's mainly based on how much demand our network is under. So in the summer, when the pressures in our network are low and people aren't really heating their houses, we have lower workload when it comes to repair. And in the winter, when we up our pressures to be able to supply all the gas for your heating and other activities, we can see up to a 40% increase in our workload when it comes to repair. That means that our workforce is sized for that winter hump, meaning that it's not as efficient as it could be in the summer. What I'm really, really trying to tell you is, at the moment, our approach is quite reactive, and it has been traditionally for a while. And we think there's a lot of value in moving to become more proactive. When it comes to our emissions, which you can see on the screen at the moment, you'll see it's really quite dominated by that orange blob. That's what we call shrinkage, and that's the loss of methane from our network over its transportation journey. When you dive a bit deeper into that orange blob, you'll find that 3/4 of it comes from this green segment, and that is the loss of gas over our gas pipes and services. So how do we surveil that green segment at the moment? How do we understand where our leaks are coming from? At the moment, we use human legs, right? And these human legs have gas analyzers walking our assets, as you can see on screen. This technique comes with two main challenges. One, as you can imagine, it's not very scalable. So covering that 131,000 kilometers of our network consistently every year is not really practical. And two, the result of it is binary. We know whether we do or don't have a gas leak in a specific location. What we don't know is to what degree, how much, and we can't prioritize with the results. So over the last year or so, we've begun to shift towards a new technology. And this is called advanced mobile leak detection. It gets retrofitted into a normal car. We've got a fleet of Ford Cougars at the moment. And the kit comes with a couple of different sensors. A methane and ethane analyzer in the boot, and that allows us to tell the difference between natural gas and biogenic sources of gas, such as from farms or sewers. On the top, you'll see it might look like a Google cars, like webcam. That is a wind speed and direction sensor, and there's also a very highly accurate GPS on top as well. And what happens is the data that's streaming from all these sources is plugged into a model. At any point, the car knows what concentration of natural gas it's passing through, where it is, the wind speed and direction. And from that, it's able to triangulate exactly where a gas leak is coming from, up to 200 meters away from the car. And very critically, we can measure the flow rate of natural gas coming from the leak, which means we can then start to prioritize our biggest emitters and react and go out and proactively fix them. So bringing it back to those initial work streams, on the screen you can see the traditional leakage reduction pathways of those two work streams. So replacement, you gradually reduce your emissions over time, and through the prioritization of those works, you try to target the assets that you have that are leaking the most at the start of the program, so you can get the most value out of your money. So you'll see that the gradient begins to tail off over time. When it comes to repair, because we're not really prioritizing based on emission rate, it kind of just keeps our emissions stable. When you bring in this new technology, you can start to have a really big impact to those emission reduction pathways. In replacement, you're no longer using reactive data to prioritize. You're starting to use data on where you have leaks now. And through that, we're able to better prioritize exactly where we should be targeting our replacement programs. And we can accelerate the emission reduction pathway. When it comes to repair, there's a complete transformation. We go from a work stream that just keeps our emissions stable to one that is now a really, really effective tool at reducing our emissions. And you can really start to drive them down over time. What's important here is that by implementing this new technology and taking a proactive approach, we can really enhance our existing work streams to reduce our emissions. So I've talked to you about how we've changed our surveying approach. You must be thinking, well, surely that car comes with a lot of data that you have to manage as well. And we've had to change our approach as to how we do that. And this is where we're using ArcGIS Online's dashboards to visualize the data, understand it, and action it in the best way. What's really important here is that none of this data that I'm about to show you requires any sort of manual input, upload, anything like that. It's all streamed from our service provider's ArcGIS Online environment, and I set it all up. And I don't code or anything like that. It's quite easy. So I'm going to pull you into the dashboard, and this is an example. What you'll see on the top left is a few black boundaries. Those are survey boundaries that we give to our drivers, and it takes about 2 days to cover one of those boundaries. On the right-hand side, you'll see some KPIs, such as the emission rate in those areas. And you can see we've driven 5 boundaries between the date. And on the bottom, you'll see some data tables that are useful. As I zoom in, you'll start to see some colored blobs. And these can resemble Pac-Man. Those are leak indications. They're the bits of data we get from the car, and their size is based on how confident we are of the leak locations. So some of them can be a bit wider, even a circle. Where we have them, we're not as confident on the position. And if you are an engineer and you are visiting these to confirm that there was a leak there and action further work, you would look directly within this polygon shape because the leak will be within there. As I click on it, you'll see it comes with a bit of metadata. Really importantly, when we found it a unique ID, and, as I mentioned earlier, the emission rate, the emission flow rate that's coming from that leak. And that allows us to start to prioritize. There's a number of filters in this dashboard as well. So you saw that we had time data in there, and we can use that to see what's trickled into that dashboard in the last 7 days. So, for example, in the last 7 days here, just this boundary has trickled into the dashboard. And you'll also see there's quite a few of these shapes, these leak indications. This tech is really, really sensitive, and it will pick up leak indications that you would never, ever smell, and that would never even lead to an incident. So it's important to filter those ones out when we decide which ones we're going to go to. So to do that, we use an emission filter, and we'll do that on the left-hand side in a sec. And you'll see that it brings down the number of leak indications quite a lot, from 57 to 11. If I zoom into this, this is where the power of ArcGIS is really handy. We host our other data sets in here, so it's quite easy to pull in other data sets. This is our pipe layer, and you can see that that leak indication intersects 2 of those pipes. So we'd expect the leak to actually be on one of those. Looking at this other one as well, you'll see there's an example of a leak indication on its own, and this one is intersecting 3. Moving over to this section, you'll see this looks a little bit different. This is where we've got multiple leaks across one pipe. And this is where you can start to use, map your data to understand, well, what is the best intervention? For me, there's not much point coming in here and repairing 4 times. It costs us extra money, and it disrupts. So this is a really good example of where you can map this data and go, well, repair is not the right option here. We should replace instead. So I've got an example. Recently, when we were surveying in Harrow in northwest London, we came across an area of really high leakage. And it was actually in the middle of a roundabout, meaning that no one was ever really there and would never really smell it. And when loaded up in this dashboard, we can see, well, we don't think repair or replacement is the right intervention there, so we decided to repair. And once we did repair, we went and resurveyed it again to understand exactly how well we had responded to it. And upon our resurvey, we found that we reduced our emissions there by 96%. And that's really important, because that's the first time that we've been able to kind of quality assure our repair based on a measurement. When you roll that up into a full program, last year we did over 200 of those proactive repairs. And as a result of those proactive repairs, we forecast that we've reduced our methane emission flow rate in the 11,000 kilometer area that we surveyed by 7%. What's really important is that 7% is a forecast, right? It's based on the work we've done. And at the moment, we're resurveying those areas, similar to what we did in Harrow, but for a wider picture to understand, well, is that 7% accurate? Have we actually done that? And if we haven't, or we've gone beyond that, why? And we can begin to iterate and understand our network a bit more intelligently. What these stats show is important. We can use this new technology to accelerate our progress towards our climate goals, and we can do it really rapidly. So this is the kind of the management process that we use for this tech, right? It all starts with surveying your network, understanding what you have, where your leaks are, where you should target. Today, I've walked you through how we ingest the data and subsequently analyze it in ArcGIS. But from there, you select the work, you deliver it, and then you adjust your survey frequency. And then you go around the whole loop again. And it's all about iteration. Every time you go around this loop, you discover and find something new about your asset. And once you've really gone around it enough times, you start to have a really intelligent view of the health of your network, where you might have problems and where you're good, and where you should target your investment to make the biggest difference. We're on a journey to automate this entire process from beyond just the ingest data and the analyzing data, and we want to wrap all of that around with real-time reporting. So at any moment, we know exactly where the leaks are that we found, where we're doing works, and where they're finished, to really improve how good we are at forecasting our emissions and understanding how we're going to reduce them over time. This is really exciting for our industry. An automated future is really not that far away. So I hope that what I've shown you today convinces you that with today's technology, you really have the ability to make a difference. We've started our journey. What does yours look like?